Hello everyone and welcome back to Silver IT. In today's video, we will talk about a spanning tree protocol, specifically the root bridge election. So we know that in the spanning tree algorithm, the switch with the higher bridge ID is the one that is going to be the root bridge. So we're going to see that information in our switches, and also we're going to see the configuration to modify, right, who is going to be the root bridge. So before going to the switches, I'm going to use Wireshark because there are some things that I want to share with you guys. So here I want to see the information that our switches are sending in the spanning tree protocol messages. So here we're going to the spanning tree protocol header, and here we can see, right? We can see the bridge ID of our root. So right now there is a root bridge. There is a switch which is the root bridge, and this is the root identifier, which is composed for the priority of that switch, the CCNA ID extension, which represents the VLAN ID, in this case is VLAN 1, and also we have, right, the physical address of our root bridge. So here again, this is the root identifier. The switch with this physical address is our root bridge, and which switch has that physical address? In our topology, the one that has that physical address is switch 2. As we can see here, switch 2 has that physical address. Then we see here the root path cost, which is 4, right? 4 is for interface with 1G, right? And 2 for interface with like 10G. So then here we can see the bridge identifier, right? This is the bridge ID of the switch which sent this message. As we can see here, we will see the same information. So right, if I see the physical address, I will see that this bridge ID information, this physical address matches the switch. Which one? Message switch S3. So this message was sent from S3, and that is how the spanning tree protocol work. So switches send their bridge ID, right, via the BPDU, which mean bridge protocol data units. So they share these messages, and the spanning tree algorithm calculate who is gonna be the root bridge. So that's the information that I wanted to show you. Here we can see more information regarding the spanning tree protocol, like the mask age, the hello time. So we see here the timer information. So that would be all that I want to share with you regarding Wireshark. So now, if I'm gonna let's use some commands row. So let's use a spanning tree. First, I wanna show you the protocol that we are using, because we are not using the old spanning tree protocol. We are using the per VLAN spanning tree. So we use the command show a spanning tree, and in that case, we are going to use the keyword summary. And as you can see in our first line, we see that switch is in per VLAN spanning tree mode. So this is the mode that we are using. So now, okay, so now I'm going to use the show a spanning tree. In this case, I can use the bridge, right? And what we can see here, so let's try to take more. Okay, so here let's okay, so here with the show spanning tree bridge, we can see more details, right, specifically of our switch. So here for S1, we can see here the physical address of this switch, the extended system, which is the VLAN, and the priority. We can see also the hello time, the max age, the forward status, and the protocol. So now another useful command is the detail command, the show spanning tree detail. So with this command here, we can see, right, this is the instance per VLAN spanning tree. We need to remember that make an instance based on VLANs. So we can see here that for VLAN 1, for this instance, this is the root, right? This is the root, and okay, let's say bridge identifier. Sorry, that's not the root. This is the bridge identifier. This is our local switch, right? And this, let's look for, let's see. This is the hello time, formation, current root has, okay, yeah. Here we can see that the current root, this is our root bridge, has this priority, and this is the physical address of our root switch. So we can see here more information. For example, we're using this port. So this is the port that is using to communicate with the root bridge, which is number 2. Right? Why number 2? Because we see here port 1 is gigabit 00 and port 2 is gigabit 01. So that's why. So we can see those details, and also specific information regarding the interfaces like the cost, the priority, the port identifier, and so on. Okay, so that was enough. Let's use the active command. Sorry, the active keyword. So here we can see, right, almost the same information but more organized for me. So for the VLAN 1 instance, we can see here that this is the root identifier, right? This is the physical address of the root identifier, the timing information, and this is the bridge ID of S1, of switch 1. Also, we can see the interfaces, the role of each interfaces, the status of the interfaces, the cost of the interfaces, priority number, and type. In here, peer-to-peer, because it's directly connected to another network device, right? So now, how we can change our root, right? How we can modify who's going to be the root. So we need to go to the global mode, and from here we can use the spanning tree command, follow. In this case, right, because we have per VLAN spanning tree configure. Okay, just in case that we need to change like the modes, we have here the multi-spanning tree protocol modes, the one that we're using, the per VLAN spanning tree, and the rapid per VLAN spanning tree, just in case that we wanted to make, right, some changes in here. So, but as we're using per VLAN spanning tree, the modification that I'm going to do is going to affect VLAN 1. So I can go with the keyword priority, and we can see here, right, this is the range from 0 to 61,440, and increments of 4,096. So right now, S2, right, is the root bridge. So this is the priority. So 4,096 is lower than 32,769, right? Now, the default priority for all switches is 32,768. That's the default priority. I forgot to mention that at the beginning, but that's the default priority. And due to the VLAN, right, VLAN 1 that is added to the priority, we got the 69, but it's 68. That's the default priority. So now we're going to make our switch 1 our root. So now, let's see, I closed Wireshark, but now the switches should be like sending messages to notify about basically the topology change, right? Because now we're going to get another root, and as we can see here, now the root has been changed. Now our root has this physical address which belongs to switch 1. So we will see more details later about what happened when the topology changes and all of that. So, but now if we do a do show spanning tree, right, and active, we will see this information, right? This is the root ID, the priority that we set, and this is something that identify the root bridge. When the local switch is the root, we see that message, this bridge is the root. So if we go here to switch 2, we will see that that message only appears in the root. So we don't see that message because this is not the root bridge. So that information always showing in the roots. So that is how we can change who is gonna be our root in our topology. So another way we can select the, so let's see the other way we can change this. So let's use the command spanning tree, in this case VLAN 1, right? And we have the keyword root. So root has two options. The first one is primary. In this way we can set, right, the switch, the current switch as the primary, or we can make it the secondary. So let's use that command right here in S3. So let's go here, spanning tree VLAN 1. So we are going to set as our primary this switch. And so now the changes, I mean, as they send their BPDU, they will be notified who's going to be now the root. So let's see the show spanning tree active. Okay, so here we can see this bridge is the root. So now here, if we show a spanning tree active, we can see here that this switch is not anymore the root, right? But this switch. So this is one way. This is the other way we can use to make this switch the root, using the command show a spanning tree, right? VLAN 1 or VLAN 67, right? Depending on the VLAN instance, then root and primary. And we can make, for example, let's say in case the switch 3 goes down, I want switch 1 to keep being the root. I mean, to take ownership of the of the root thing. So how? The same spanning tree, VLAN 1, root, secondary. So if for some reason, for example, let's make it this way, this should work. So here, right, S3 is completely out of the topology, so we only have switch 1 and switch 2. So who's gonna be the root bridge? Let's see. Okay, let's see. I don't want to eliminate the interface, but I will have. Oh, okay. I don't know why I didn't see the message, but the message is here. So as we can see here, this is the root because we said that this is the secondary. So if the primary goes down, the secondary will take ownership. So that is the different ways we can modify who is going to be the root bridge in our topology. So I hope that we have learned how to make these changes and how this spanning tree protocol works. So if you have any question, any doubt, please leave it in the comment. I'm preparing. I mean, I have the other lab set up for the spanning tree. So don't remember to subscribe. This is the way that you can support this channel and help me, right, to create more contents, because I know that people are using my content for good, right? So like and share this content with any people that need it or it's in the field. So see you in the next video.